Hello all, and welcome to this agentic AI course. In the last video, we have discussed how AI technologies evolve from machine learning to the agentic AI. And in this particular video, we will start with the framework which we are going to use to implement our agents or implement our agentic AI workflows. So before starting with this video, let's start with the recap of previous video. So let me open my notebook here. So in the last video, we have discussed what is machine learning. So let's have a quick recap so that it will be easy for you to come on a track. So let's say first we have discussed machine learning in the previous session. So machine learning was the basic form of AI. We can say it's a subfield of AI which train on input data. We have to pass the input data, which should be labeled or sometime unlabeled, and then learning happens. And for learning, we have multiple machine learning algorithms. And on the basis of that learning, we predict the future event without explicitly programmed. Like the main benefit of machine learning is we don't need to write the rules manually. Just like a rule-based system, all the rules are detected by using machine learning algorithms. Now, we have seen there were some limitations with machine learning, like feature selection was mostly human dependent in machine learning. Like we can use some technique, but mostly human interference is there. Then machine learning algorithm mostly get saturated if you increase the data size. So data size issue is also there in machine learning. So both of these issue were solved by using deep learning. So deep learning is the subfield of machine learning which use neural networks. So we had already discussed uh, how neural network actually works in the previous session. So neural networks are capable of handling complex rules or finding complex rules, complex pattern, and even deep learning algorithms are capable of finding automatic features. Like the feature selection was also solved in deep learning. Okay, but still, deep learning is evolutionary technique, but there are some limitations associated with deep learning, and these limitations are we have to build individual model for individual use cases. Like let's say for image classification, the model can be different. For sentiment analysis, the model can be different. Okay, so this problem solved in generative AI. So in generative AI, we got LLMs. LLMs are the large language models. We say foundational models. So most of the organizations train their own foundational model on the huge amount of data, and these models are capable of solving multiple kind of problem by using this single model. Okay, so now it's possible to solve text generation, image generation, and code generation by a single foundational model. Okay, this is the benefit of or the power of generative AI. Now, next is limitation. So, the generative AI applications or the applications which are based on LLMs, mostly we call it a chatbot. These chatbot are reactive chatbots. Means we ask question and chatbot react on this question. If we say, what is the weather in my city or what is the temperature in my city, then in that case, chatbot react. So they are not autonomous. The chatbots are not autonomous. Then we started exploring the most important concept, which is agentic AI. Our complete course is based on agentic AI. So agentic AI is a system or the way by using which we can create a chatbots, mostly a chatbot, but these chatbots are agentic in nature, means they are autonomous. They can take decision on their own with a limited human intervention or human uh, permissions, we can say. Okay, now in agentic AI is mostly the concept, but here we talk about AI agent. AI agent I have added, like we have learned this simple definition of AI agent, which is the AI agent is a system which can autonomously perform tasks. I have highlighted two, three words here, and this is very important. Like autonomously perform task means you don't need to perform each and every action. You don't need to participate in each and every action. Most of the action were performed by the agentic AI agent, mostly agent on its own. Then it can plan means create workflow. Let's say the task is divided into multiple part, then agent define the plan, like this is my first step, this is my second, this is my third step, just like that. Then with the integration of available tools, so your AI agent can integrate with available tools. We have discussed this part in the detail in the last video. If you are not watch this, just go and watch this video first, okay? And on the behalf of user means you don't need to enter, you don't need to participate in every action. You just give the instruction, the first instruction or the complete task you have to achieve. Your agent will start working on it. Okay, that's it. So this is the robust definition we can say for AI agent. Then on the basis of this definition, we have find out some properties or the features like autonomous, planning and reasoning and tool used. Then the most important part which we had discussed, like these are the key feature of agentic AI. Agentic AI means these are the key features associated with agents. Okay, so autonomy we already discussed. We your agent will not wait for a user to perform each and every task. Once you give the instruction, it start planning and start working. Okay, then it can use external tools. Then it will break down your task into small tasks. We can say planning and reasoning. There are so many things that are also there in planning and reasoning. Like let's say you divide your task in particular sections, but one section is not possible to complete, then in that case your agent decide the another way. We'll discuss this in today's session. Then error handling, if something happen as not per as per the expectation, then agent react on this and perform the corrective action. Then it uh, it follow memory. We call it as state. It carry out state through all the steps. Like let's say these are my steps, first, second, third. So memory of all the steps will be there at this position also. Okay, this is what we called as memory. So these are the key features we had discussed in the last video, and the example we have seen is like this simple example. I want to get fitter, but only have 30 minutes a day, and we just have introductory discussion like how your agent divide your task into multiple subtasks. Now, in today's video, we'll see what is LangGraph framework, what are the components of LangGraph, and we'll see one example end to end, like how actually theoretically AI agent think and work. Okay, so this is all about the data we which we have completed or the syllabus which we have completed in the previous session. Now it's time to start our today's session. Let's start with the simple definition of LangGraph. So as we have created simple definitions for all the previous concept, we will create a simple definition for LangGraph also. So let me add the definition. So LangGraph is open source. Okay, let me adjust the font size here. LangGraph is open source orchestration framework which can use to build, manage and manage and scale stateful AI agents or stateful AI agent systems. Okay, so this is the simple definition we can use to understand LangGraph, and this definition capture the complete essence here. Okay, so let me highlight this definition. Okay, good. So now here, if you say your LangGraph is open source, so you can use it anyway. Orchestration framework means it can allow you to coordinate with multiple components. Orchestration means the middle component which can coordinate or link with multiple components. So by using orchestration or by using LangGraph, you can connect your agent with multiple systems. Okay. Then another word here is stateful AI agent. Okay. So we'll discuss orchestration as well as stateful word also. The simple definition for orchestration. So I will add the word here. Coordination between multiple component of system. Okay. Orchestration is nothing but coordination between multiple component of your system. This is what we call as orchestration. And then one more important word here is called as stateful. So let me highlight this. Okay. So let's resume from the point. Like there was a technical glitch happens in my system. So let me start again, which is stateful. Okay. So we are why we are going deep into this definition. The reason is once we understand the definition, we will understand the capabilities of LangGraph, like what we can achieve by using LangGraph. Okay. So the one thing which is orchestration framework. So we can coordinate with multiple component of system, like the external tools, external data if required, so many things, the APIs, LLM APIs, so many things. We can integrate with multiple components by using LangGraph. One more thing which is stateful application. So stateful means system which carry past context or memory. Okay. So stateful applications or stateful AI agents mean the systems or the agent which carry the past interactions. As we have discussed, state. In the past video, we have discussed the topic which is state. State means your memory. So the best word to understand here is memory. So you can create these stateful agents by using this line graph. Okay. Let me add the arrow. Yes. Okay. Here, stateful means the system which has awareness about all the steps, past steps. So if you talk about the example here, let's say here I am building one AI agent and the task, the agent is doing one task which is divided into 7 steps. Let's say step 1, then step 2, step 3, step 4, and okay, let me finish at 5. Okay, step 5. Okay, let's say your tasks are divided into 5 steps. One, two, three. Okay, just a minute. I forgot to add 4 here. Yes, good. That's it. So your agent should remember what happens in step 1 when he's executing step 2. Your agent should remember what happens in step 2 when he's executing step 3. So the context or the topic I'm explaining is linear workflow. Like after step 1, there is step 2. After step 2, there is step 3. After step 3, there is step 4. But in some cases, there can be another kind of workflows. We'll see in the next sessions. Some kind of like conditional workflow. Sometime you have to remember this memory for this. Sometime you have to go here from here directly based on the conditions. So there can be a parallel workflow, there can be a conditional workflow, there can be a sequential workflow. So memory or the past history of interactions is very important to remember. And keep in mind, if your chatbot or if your system is not stateful, then this is not agentic, because main part of agentic system is context of past interactions or past actions. So stateful application or stateful AI agents are having past context or past memory. But what is the another word which is for stateful? Some applications can be stateless also. So the opposite of stateful is stateless. So Hope you understand what is stateless now, because we know stateful, so it's easy to understand what is stateless. Stateless means system whose actions are isolated and not connected and not carrying any context. Simple. This is the definition we can use for stateless now. Okay, so I will add here just like that. Okay, so we understand this is the simple one line definition, but in this definition, we understand two most important concept, which is one is orchestration and another is your, let me highlight this also. Okay, another is stateful. Now it's time to move next, which are the components of LangGraph. Okay, so I hope you got the idea like what we can achieve by using LangGraph. So LangGraph is just a framework. In simple word, it's a Python library, because we install LangGraph in our systems. We'll install this in the practical session in the next video, and it's just a Python library or a Python framework which we can use to orchestrate. Okay, now let's move to the next part, which is component of LangGraph. Mhm. So let's move to the component of LangGraph, the important component which are necessary to study before building a practical AI agent. Okay, so let me put a heading here. Component of LangGraph. Okay, I think. Okay. So in components, before starting with LangGraph component, we need to discuss one word here, which is very important, which is graph. Okay, so LangGraph contain the word graph. But do you know what is graph? Graph is simply a data structure. Okay, it's a kind of data structure we use, which has few components to study. So let me create a system, or let me create a diagram here. So suppose here is my system one. Okay, then okay, just a minute. This is second, this is third, okay, and this is fourth. Okay, and let's say I am connecting this by using a line. Okay, so this is connected with this, again this is connected with this, and this is connected with this. Okay, it's a kind of flow chart we can say. Okay, so you can consider it as if else statement. Okay, so either your flow can be from here to here to here, either no, just like yes no question. Suppose if we talk about this, so let's say if yes, then again यहाँ पे let's say here yes. Okay, and let's say if it's no, you can take any example. It's a simple if else, but you will understand why we are explaining this and why we are studying this here. This is no. So in this system, let's flow chart for some time. Each individual component is a node in graph. Each individual component of your system is node, and the line which connects those components is called as edge. So if you talk about graph data structure, so in graph data structure, two important components are there. One is node and another is edge. So, and third component is execution, control of execution, which is the flow. Like your control starting from here then go here. This is what we call as control of execution. So these three are the most important component for graph data structure. So graph data structure is different part. We will not dive deep into it, but these components are important for LangGraph also. Okay. So let's say I will explain this with an example. So let's say take a simple example. Uh, let's say we are building a system to check other mm, loan application of any candidate. So let's say this is your element which is check past loan history. Okay. So this is your first node which is check past loan history. So we will create a Python function for this, and on the basis of that, you will get good and here bad. Okay. And then if it's good, then check any like CIBIL score. Okay, it's a simple example. Maybe it will not relate with the actual problem statement of loan application, but for an example, we'll study this. So if your history is good, then you will check CIBIL score, and then your loan accepted, and here this block is rejected. So the thing is, which we have to study here is we don't need to talk about this example here. The only thing we have to study is this component. The individual component or the individual Python function is called as node, and this is age. Okay, so this diagram will help us after the example. Okay, so for now, I will consider it as node. Okay, this is your node and age. There are multiple ages. From here, I will add a few ages. Like this is your age, then this is your age, and also this is your age. These three ages are there. And if you talk about node, then we can have multiple nodes. I will highlight node also. So this is your node, then this is your node, then this is your node, and this is your node. Okay. Now let's start with the component of LangGraph. So just like we have seen in this diagram, your LangGraph component, the important components are again node, age, state, and control. Okay. There might be a different word for this control, but I will use the simple word which is control so that it will be easy for us. Okay. So these are the four important component of LangGraph while building AI agent. Now, in order to study this, we'll carry one example. Okay. Parallelly, we will follow an example and we'll understand how these components are correlate with this example. So let me clear this diagram first. Example is order a burger for me under 300 rupees from a restaurant with rating higher than 4. Okay. Just a simple example. We'll study this example in detail and parallelly we will understand the component also. Okay. So this is my example. I put this prompt to my chatbot or the agent and my requirement is just order a burger for me. Okay. Whose price should be near or below 300 and the restaurant rating should be higher than 4. So if you talk about this task, this is not a simple task. If let's say before diving deep into this in agentic way, let's understand if we are a human, how we can execute this task. So how we can execute, we will open online food delivery application. We'll check burger, we'll search burger. Then we'll see prices. Then we'll filter out restaurant on the basis of prices. Then we'll check whether the burgers which we are selected are from the restaurant whose rating is more than 4. Then again we filter out on the basis of rating. So this is our way to execute this task. But and we have to perform this task by using AI agent. So let's say how AI agent will execute this task. So first part here will be requirement. So the first part your agent will do is going to be the requirement extraction. Okay. In requirement extraction, what will happen here? Here it will extract the actual requirement. So requirements are, so I will add this in a dictionary better. And let me increase the font size here. First thing is item. So item is burger. Then another is price, or we can say max price is 300. Minimum rating is equals to 4. So these are my requirements. So the first step to solve this problem is requirement extraction. So your chatbot or the agentic AI system or agent we can say will extract your requirement, and your first requirement is understanding the what actually we have to execute. So now your goal is clear. Goal is to order a burger, and max price is 300 and minimum rating is 4. So now next is creating initial state. Your next operation is creating initial state. Initial states means the initial memory which we are carrying throughout the steps or the multiple steps. So I have created this memory somewhere. Let me find this. So I will add here so that we can save our time for this. So I have added the initial state of our system here. So let's see. Once we extract the actual requirement, then next is creating initial state. Initial state. Okay. So we added one component here, state. So state is simply a memory or context which travel. Okay, just a minute. Across nodes. Okay. So we'll see. We'll jump on nodes also. But let me add the first part, which is state. So state is nothing but your memory or context which travel across nodes. Okay. And here, this is our initial state. So what is the important of this state? Okay. So let me explain this in a simple way. Now your item is again burger. Your maximum price is 300, minimum rating 4. Now the new part is restaurant found. Okay. Then selected restaurant. At this point, there is no restaurant selected. Selected item, still there is no burger selected. Order confirm status is false because still we are finding. Now, if you just scroll here, if you just find here, could you see there is a part called as restaurant found. Okay. But in order to find a restaurant, you need to perform one action. Okay. You need to perform, or you need to write a simple function. Okay. So let's say you write a function here. So I will just for example, I will add here function to find the restaurant whose rating is higher than 4. Okay, so it's a function. I will say for better clarity, I will say directly Python function. Okay, so you're writing a Python function which can find out the restaurant or the list of restaurant whose rating is higher than 4. So when you run this function, you will get restaurant found. This list, this is a list, this is a simple Python list. And once you run this function, your list will get updated. And now this list will not be empty. This list will not be empty. This list will have something. Okay. Now, here, if you see, first is restaurant found, then selected restaurant. So maybe your function initially will found all the restaurant, then select restaurant on the basis of rating. Okay. So this node, this function is what we called as your node. The individual program or the Python function which perform one action during the flow or during your agentic operation. Okay, so this function can be your node. Okay, this is just an analogy we are having, so you will get the idea. So let's say this is my first part, which is requirement extraction. Another is creating initial state. But do you see, in order to run this function, let's say you have to run this function, which is find a restaurant uh, whose rating is more than 4. Then there is another function, we can say, for example, restaurant which serve burger. Okay, this is also the condition. So either we can add multiple functions for this. Okay, so this is your again one condition, restaurant which serve burger. Then rating, two conditions are there. Okay, so after this function, after this function, this state will get updated. Even after this function, your state will get updated. And at the end, you will get the most latest or updated state. So this is the simple analogy we can use. Okay. So now let's continue our flow. Now first is requirement extraction. Other is creating initial state. Now let's move to the third part. So next step is, after this, next is we require data. Okay, so let me explain again. We have discussed like Python function to find restaurant whose rating is higher than 4, restaurant which serve burger. So these are the individual tasks in your system. And the component of your system which perform this individual task is called as node. So let me add the definition here. Okay, function. So in our case, let's say directly Python function which perform one task or single task, we can say. Okay, so in our case, we have added one example, which is Python function to find the restaurant whose rating is more than 4. Restaurant which serve burger. So I will add this example here. This is your example. Okay. So we added node. Now, what is remaining here? Age, state, state for state we added this. And let me arrange this properly. Okay. Now it's fine. So first is node, another is age. Age is still remaining. We'll see this age part. And last is your control. So let me shift this here. Okay. Now next is external tool integration, or I will say tool integration. Okay. So let's take the flow again. So now first we have seen requirement extraction. So for requirement extraction, there will be a function, Python function. This is also one node. Then creating initial state. Initial states means your initial memory, which will travel through multiple nodes. Now, every node, this state will get updated. Once you run this function, you will get a new restaurant list whose rating is higher than 4, like that. Okay. Then at the end, you will see true here, like your order will be confirmed. So now next part is tool integration. So here I will add extracting the restaurant data from food delivery app API. Okay. So we need to run a function which can extract the restaurant data from the food delivery application, the online food delivery application. We need to connect their API and we have to extract this data. So this is the third step. Okay. Then next step, logically we can say once we have the data, next is filtration. Filtering this data. Now here we will write multiple functions like this kind of functions. So let me add this into the same bracket. Okay. So the sample functions can be, first thing we need to study is restaurant which serve burger. Then uh, restaurant whose rating is higher than 4. Then again, so these are the two main conditions. Like we need restaurant which serve burger and Python function to find restaurant whose rating is higher than 4. But again, we have one filter, which is function to find burger based on our price requirement. Okay. Now we can change this flow. We can change this flow, like maybe first this will be first, this will be second. Okay. Once we practically do this, we will change this flow. But now just for understanding, we can see we can perform filtering on the basis of this requirement. And now could you see when we run this function, restaurant which serve burger, so we'll get this list updated. Okay. So I will add this case again here. Okay, just for an example, so that it will be easy for everyone to understand how actually agentic workflow happen. Okay, so here I will add this one. So could you see this is your function? Once we run this function, restaurant which serve burger, this list will get updated, and now we have restaurant one. Let me copy this part from here, then two, then three. Okay, so now your state is getting updated, and what we have discussed about state is nothing but your memory or context which travel across nodes. So in this node, now your state is updated. But could you see, if you talk about, let's say this is your Python function. Okay, this is your Python function, and if this Python function is returning the updated state or updated memory, so what could be the input of this function? Okay, it's logical question. If this function is returning the state, then what could be the input to this function? So the input to this function is again state. This function take previous state as an input, then update this state based on the logic we added in the function, and then will return the updated state. Now, our next function is again Python function to find the restaurant whose rating is higher than 4. Now, for better, I will remove this word. Now you understand, like this is a Python function. Now again, this memory or this state is getting updated. So selected restaurant. So restaurant 2 and 3, these are selected. Okay, based on the rating, let's say selected item. So burger, we can select here. We can write burger here, but we have to add this in a new function. But logically, let's talk about the next. Okay, so again, update this memory here. Good. And now selected item, we can say burger one from restaurant one. Then let's say you can add this list. I will not add everything. Okay, so this is your third node. So for example, we have added three nodes. First is restaurant which serve burger. Another is restaurant whose rating is higher than 4. And then burger, finding burger based on our price. Finding burger based on our price. Now, at this moment, could you see your initial state is completely updated? This is your first state or memory. Now you have this kind of data. Okay, so what we have to study here. Okay, let now next is what is remaining? False. Now your agent will ask user that I found this restaurant and I found this burger based on our condition. Can we go to finalize the order? So here your agent will ask you, I found those results based on our condition. Can I proceed? Okay. Here is the question from agent. And if your answer is yes, then it will move to the next step, which is payment. So if he has access of your payment application, it will perform payment also. And then your after your payment, the final memory will be order confirm true. This will be updated at the end. So this is the simplest way we can use to study how agentic workflow happen, how agentic workflow perform, how we perform agentic workflows. Okay. So this is the things actually present in any AI agent. Okay. Then now what is remaining from our component, which is age. Age is nothing but the part between your node. Okay. So your edges are nothing but component between your node. Okay. This is the component between your node. And edges can be, okay, just a minute. Let me correct this. So let's define the node age again. Age is nothing but your component between your nodes, which define which node runs next. Okay, it define the flow of your execution. Okay, let's take an example. I will put an example. Suppose we run this function, which is restaurant which serve burger. Okay, or restaurant whose rating is higher than 4. So this is a simple function. But what if we never get any results? So let me copy this example. What is the function? Restaurant with rating higher than 4. Let me add here. Okay, restaurant whose rating is higher than 4. If result is equals to none. Okay. Then uh, age decide, sorry, decide to run this node again. Okay, sorry for the spelling mistakes. Okay, that's it. So it's a simple example. Okay, so age is nothing but your the component between your node which define which node run next. So we have taken one example. So what if we never get any restaurant whose rating is higher than 4? Then in that case, your control or your age will connect it to this function again, will connect this function and run it again. Okay. So on the basis of this example, we can say your age can be, or it can be sequential or conditional. Okay, your ages can be sequential or conditional. So this example, on the basis of that, we can study uh, either it's sequential or conditional. Now we have seen the condition, like if we never get any restaurant, then we have to run again. So your age will connect to that node again. Okay, so that's it. This is all about the age. So first is node. Node is nothing but a Python function which performs single task or any small component, any individual component of your system. Age is nothing but the component between your node which define which nodes run next. Now state, the most important, the heart of your system, which is memory or context which travel across and node. And control is nothing but the overall coordination between ages and node. Okay, how the control will happen is nothing but the control part. So I have just added the generalized term, the complete coordination between multiple nodes and edges. That's a simple definition we can use here. Okay. Okay, that's it. So this is all about the component of LangGraph. So these are not the only component of LangGraph, but as we are starting from beginning, these four are very important. We'll see the remaining part, remaining, there are multiple functionalities also in the LangGraph. As we move forward, we'll see those parts also. But for now, in order to start coding, this is important. What is node, what is age, what is state, and what is control. Okay. So let me revise the example again. Okay. So our example was to order a burger from a restaurant with rating higher than 4 and price should be under 300. So first is your requirement extraction. First function, first node is requirement extraction. So do you see how requirement can be extracted from this text? Okay, so mostly in order to perform multiple actions in this workflow, we use large language models, which helps to complete the operation of multiple nodes. Okay, then creating initial state on the basis of this requirement, initial state is getting created. Okay, then this state is getting updated at every node at the completion of every node. Then we integrate external tools like food delivery API to extract the restaurant data. Then we filter this data based on multiple nodes, multiple conditions by using multiple nodes. Okay, then at the end of every node your memory will get updated, and at the end we'll get the final memory, and your order is getting, or our order is getting place. So this is simple example we can use to understand how your agentic workflow happen. There are multiple workflows are there. We'll see those workflow from the next session. We'll perform the practical also. But for now, the theory which learn is very important. In the last session also we have studied some theoretical part. In this session also we have seen the theoretical part. Now, from the next session, we'll see how we can implement this theory in practical. Okay, so before wrapping this video, let's have a quick overview of what we have studied in this session. Okay, so initially, in this video, we started with LangGraph. So the definition we have seen was LangGraph is open source orchestration framework which can use to build, manage, and scale stateful AI agent. We also studied what is stateful. Stateful means the system which carry the past memories, interaction, and context. Whereas in the opposite of stateful, there is stateless. Stateless system which are isolated. Each action of stateless system is isolated. No memory travel throughout the system. Then we have seen the important component of LangGraph, which are node. Node is nothing but the single component of your system which performs one individual task. Okay. Then age is nothing but the component of your system which define which nodes to run fast. So age is very important to decide the control or the execution flow of your system. Then we have seen state. State is one of the most important part, which is the memory of your system. And lastly, the control. Control is a general term which we can say like the complete coordination between multiple nodes and edges. Okay. And apart from this, we have seen one example in detail. I hope this example will give you the basic idea about how agentic workflow happen. Now we'll see the remaining part in the next video. Till then, you can practice this part. We'll see the remaining part in the next video. Okay, thank you.